Hi, today we're going to be learning about types of chemical reactions. There are 5 different types of chemical reactions, and they're all pretty much easy to identify if you learn these basic steps. Well, the first type of chemical reaction is called a combustion or composition reaction or synthesis reaction. This is when two things are coming together. Maybe this could be like two people who fall in love. And here you go. You got A plus somebody and X, and they come together and form a new product. So you learned what a chemical reaction was, and chemical reactions produce new products. So here's an example of one. In this case, we've got iron and oxygen that are coming together to make iron oxide. Now this isn't balanced yet, but to balance it, I've got 2 O's here, and I've got 0 there, so I'm going to put a 2 over here. And finally, since I've got 2 irons there, I'm going to put a 2 over here, and I've got 2 irons there. So what you see is two solid iron atoms combine with 1 molecule of oxygen gas to form iron oxide. So the first step, once again, composition reaction. 2 things are made. The second type of reaction is called a decomposition reaction. This is when things break apart. They're no longer, something causes them to break apart. And so normally we require electricity or some type of heat. So over here I have a single substance breaks down or decomposes into 2 or more new substances. In this example, I've got AX produces A plus X. And normally, once again, we need something in there to drive this reaction. Here's my example. If you take water and you put 2 electrical probes in the water, you create something called electrolysis. What this does is it splits the water molecules apart, and they combine to make hydrogen gas and oxygen gas. And this is actually how we determined what the ratio of hydrogen to oxygen was in water. Here I've got 2 hydrogens. I've got 2 hydrogens there. I've got 1 oxygen here. I've got 2 there. So I'm going to put a 2 over here. So now I've got 2 oxygens on both sides, but I have 4 hydrogens. So what I need to do is put a 2 over here. Once again, this is a decomposition reaction. 2 things are broken apart. Here's another example. In this example, I've got mercury oxide, and what's happening is this mercury is heated, or this mercury oxide is heated, and it's going to break apart. When it breaks apart, you get liquid mercury and you get gaseous oxygen. Okay? So in this case, I've got 2 oxygens there. I've got 1 here, so I'm going to put a 2 right there so that my oxygens are balanced. And finally, I'm going to put a 2 over here, so I've got 2 mercuries. All right, so once again, decomposition reaction. The third type of reaction that you guys are learning about is called a single replacement reaction. A single replacement reaction is when one element replaces a similar element in a compound. When I first heard about this, I thought, hey, this is like when a couple is going out to dinner or something, and one of the people in the couple decides that they would like an upgrade. They want to find somebody who's more attractive, who's brighter, got something better going on. In this case, what happens is similar elements, one similar element replaces another one. In this case, A and B are the similar elements, but in this case, A is better than B, so B is replaced. So it's a single replacement reaction. So this B is swapped out in place of this A. Now, in this case, this would be a positive ion or a cation, and this would also be a cation. In this case, both cations swap. You can't swap a cation with an anion because it won't work. Now, the second scenario is when you have an anion that would swap with another anion. So what we've got here is the Y is switching with the X. It's kind of complicated how this works, but generally this is a more reactive substance, and there's something that's causing it to break and split these guys apart and trade off. So, number three, so part three, here's my example. I've got aluminum plus lead nitrate, lead 2 nitrate, makes lead plus aluminum nitrate. Now in this case, I've got 3 nitrates over there, and I've got 2 nitrates over here, so I have to come up with something in between that would work with both of them. So I'm going to put a 3 over here, so now I've got 6 nitrates there, and I'm going to put a 2 over there, so now I've got 2 times 3 is 6 nitrates over there. Once I've done this, I've got 2 aluminums, and over here, I've only got 1 aluminum, so I'm going to put a 2 there. Now in this case, what you can see is aluminum is replacing lead. That's why it's a single replacement reaction. Over here, I've got chlorine gas and potassium bromide. Now chlorine and bromine both have a -1 charge, and they're both nonmetals found on the far right of the periodic table. In this case, chlorine is going to replace bromine. So this chlorine is going to come over, bump the bromine out of the place, and the bromine is going to be leaving. What happens over here is you get KCl, and that's because K has a +1, Cl has a -1. You switch the charges, you get KCl. Now, since bromine is left by itself, I have to write a 2 down there, 2 for a subscript, and that's because bromine is one of the diatomic gases. The fourth type of reaction is called a double replacement reaction. This is when we swap 2 sets of partners. Okay, ions of 2 compounds exchange places. In this case, the A and the B will switch, so now the B will be with the X and the A will be with the Y, as you see over there. Okay, either product will form a precipitate or a gas. There are ways to predict that whether or not these reactions occur, and the way you do it is you have to find out that one of these is going to form a precipitate or a gas. Over here is my example. I've got potassium iodide is reacted with lead 2 nitrate. In this case, these are the cations. The 2 cations are going to swap. What happens is now the lead is going to come over here and take the place of the potassium, and the potassium is going to bond with the nitrate. So what happens is I get lead 2 iodide and potassium nitrate. Do you see how there's a solid over there? That's another example of why it occurs. My second example is iron sulfide plus hydrochloric acid makes hydrogen sulfide and iron 2 chloride. Now in this case, this hydrogen is going to swap with this iron. So what I do is I swap them, and I remember what form of iron do I have? Is this iron 2? Is this iron 3? What type of iron is it? Well, you check over here. Sulfur has a -2 charge. Since sulfur has a -2 charge, and there's nothing down there, that means iron must have had a +2 charge. You have to keep that in mind, because now when you get over here, you're going to do something with that iron. Since this iron is now going with the chlorine, we're going to take the +2 from the iron and put it down there next to the chlorine. Over here, we've got the same thing going on. Sulfur has a -2 charge, and so that -2 is coming down to make that H2S. So that's the fourth type of reaction, called a double replacement reaction. Combustion reactions. A substance reacts with the oxygen to produce light and heat. In this case, we normally have something that has a C and an H. It doesn't matter how many of these you have. Reacts with oxygen to form carbon dioxide and water. Here's my example. CH4 plus O2 makes CO2 and water. In this case, let's balance. I've got 4 hydrogens there. I'm going to put a 2 over there. How many oxygens do I have? I've got 2 there, I've got 2 there, and 2 more. So that's 4 oxygens on this side. I'm going to put a 2 over here, so now I have 4 oxygens. Look at my hydrogens. I've got 4 hydrogens, and I'm done. I'm going to do another example of this using something else. I'm going to go C6H12O6 plus oxygen, and if you are given that, and that's all you're given, what you know is this is carbon and hydrogen, there's oxygen, and so what's going to happen is it's always going to form water and CO2. Once I've got this, I'm going to balance my carbons. I've got 6 carbons here, I've got 1 carbon there, so I'm going to put a 6 over here. I've got 12 hydrogens here, and I've got 2 hydrogens there, so I'm going to put a 6 over here. Finally, how many oxygens do I have on this side? I've got 6 and 2, which is 8. On this side, I have 6 oxygens there and 12 oxygens there, so that's 6, excuse me. I've got 18 oxygens on that side, okay? On this side, I've got 6 plus 2 times what equals 18. And so in this case, I'm going to put a 6 over there. All right, so you've learned about the different types of reactions. Now let's get to it.